In episode 49 of the CySec101 training series, we're going to go through the basics of CAPA, which is a very unique tool that we can use to identify what executable files do. So it basically looks at the functionalities of an executable to tell you what it does without you having to execute the file. And this is a very important tool. It is in our defensive security tooling module, which is a part of the cybersecurity 101 pathway of TryHackMe. And inside of this video, we're going to obviously go through the introduction of CAPA. We're going to go over the overview of how it actually works. We're going to dissect the results. So there's going to be multiple parts to this. We're going to dissect the results in part 1, the general info MITRE attack framework. So I don't know if you've heard of that before, but we're going to be talking about that, and it's a good idea for you to know about it. And then the MAEC or MAEC, I think that's MAEC or MAEC, I think it's MAEC. And then we're going to look at malware behavior catalog, and then we're going to look at namespaces, capability, and of course more information and more fun. And there's going to be a virtual machine that we're going to launch throughout this whole process. And this is a subscriber only room, so it does require that you need to have a paid subscription to TryHackMe. But if you just download CAPA on your own computer, you could essentially run along with all of these exercises with me. And most likely, if you're watching this video, you probably have access to TryHackMe, so you would just follow along with the TryHackMe room. So whether or not you have access to the TryHackMe platform is kind of irrelevant, because you can always just download the tool and use the tool directly yourself. So that is it for the overview of this particular video. If you're serious about your CySec training and want access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the supporter, agent, guardian, and master. And each tier gets their own Discord server as well as early access to content. The agent, guardian, and master levels get exclusive content, exclusive downloads, bug bounties, monthly Python automations, live streams with me every month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@hankhacks, hackers/join, and you will be able to join Hackaholics Anonymous. Now, without further ado, let us jump into the CAPA basics room. So the premise for this room and for the CAPA tool in general is about one of the biggest challenges that we actually face as security engineers and analysts. And this is when we have to potentially or analyze software that might be potentially malicious. And if you analyze it by launching it, you would expose your machine or your environment to being compromised, and it can cause you a big amount of issues. If you don't have access to a sandbox, it makes it even more difficult, or some kind of isolated environment where you can actually test everything as much as you want. So usually, if you do this with some kind of an executable file, in an ideal case, you would be able to do it inside of a sandbox environment or an isolated computer or isolated virtual machine. But what if you don't have that, right? What if you don't have access to something like that? So generally speaking, there are 2 types of analysis that you could do. One of them is dynamic analysis that actually happens when you launch the software, when you launch the executable. And the other one is static analysis. And what we're going to be focusing on in this particular video is the concept of static analysis using the tool CAPA. Now, CAPA stands for Common Analysis Platform for Artifacts. So it's an analysis platform, and we use it to analyze artifacts. And it's a tool that's developed by the FireEye Mandiant team, and it's designed to identify the capabilities present in executable files like a portable executable, which is PE or ELF binaries or .NET modules, shellcode, and even sandbox reports. So it does this by analyzing the file and applying a set of rules that describe common behaviors. And it allows it to determine what the program is actually capable of doing, like if it's going to establish a network communication, if it's going to manipulate files, if it's going to inject something into your processes, and so many more things. So whatever the executable is designed to do, essentially CAPA can help you identify that without you having to run it. What CAPA does is that it encapsulates years of reverse engineering knowledge in an automated tool, which makes it accessible even to people who are not experts in reverse engineering, which I'm not, right? So I can't look at the source code of a really complex application and be like, oh, okay, this is where the problem is inside of the source code. I can't do that. I'm pretty decent with Python. I can write automations in Python, but that's kind of it, right? So if I looked at an application source code, I wouldn't be able to tell you if there are vulnerabilities inside of that source code. And that's what this specific tool helps people like me do, right? So if you aren't good at reverse engineering code and trying to find where vulnerabilities are or exploits have been injected into the code, this is why CAPA can actually be very helpful for you. So it's very useful for analysts, security professionals, which allows us to quickly understand potentially malicious software functionality without actually reverse engineering the code. So that's the whole idea here. It's useful in malware analysis and threat hunting, where understanding a binary's capabilities is crucial for incident response and defensive measures. So we're going to explore what CAPA is. We're going to learn how to use it, understand the common fields and results that are rendered by it, and leverage it to identify the program's potential activity. And the prerequisites for this would be the MITRE attack framework. And this is actually a really powerful framework in general for you to have access to. I have done a video on this. I've actually done a couple of videos on the MITRE attack framework. So if you have not checked it out, I highly recommend you check it out. You can do just a search on our channel for MITRE and you'll be able to find the couple of videos that are available. You can also just go to Google and type in MITRE attack, and you do it with the ampersand, right? So I think even if you did like a attack with an A right here, it'll still show up for you. And this is what literally the first result is. And when you click on it, it takes you to the attack matrix. And these are essentially all of the techniques and tactics that specific attack oh my god, my brain just had a fart. So these are the techniques, tactics, and procedures that advanced threat groups have done. So there we go, that's what it is. So we have advanced threat groups, we have hackers, we have state-sponsored attackers, all of these different malicious actors who have attacked different organizations, governments. All of the data that's been gathered from all of those activities has been stored inside of the MITRE attack framework, which is a very, very powerful resource for anybody who wants to get access to threat hunting. So for every single one of these categories right here, so let's say initial access, you have 10 techniques under initial access. You click on any of them and it'll take you into that technique and it'll give you a bunch of examples of the procedures, meaning the various times that it was implemented. It'll give you examples for mitigations. It'll give you detection mechanisms, and of course all of the reference points. And then what's interesting with this is that, you know, you can click on any of these. So let's say I click on Agrius and it'll take me into the Agrius group profile. And so this is an Iranian threat actor that's active since 2020, notable for a series of ransomware and wiper operations in the Middle East with an emphasis on Israeli targets. Public reporting has linked Agrius to Iran's Ministry of Intelligence and Security. So, you know, it just so happens that the first thing that I click on has to do with my home country. So I have no affiliation with these guys, just in case you want to get smart about it and go crazy in the comment section. But it shows you all of the details of everything that Agrius has actually done and the types of attacks that they've done, the types of software that they've used, so on and so forth. So the MITRE attack framework, the MITRE attack matrix, the MITRE attack website is extremely useful, and you can get a lot of very powerful threat intelligence from this specific resource. And this should be something that you visit regularly just for your homework, for individual research if you want to do it. If you read something about some kind of attack group, advanced persistent threat group, any of these things, if you want to get more information about it, more likely you can find it on the MITRE attack website. So that is that little tidbit on MITRE attack. And then there's a bunch of different videos on MITRE attack as well, where we really dive deep into how to actually use their website to gather threat intelligence. So I've already launched the virtual machine. It's actually up and running. We're going to be using it in a little bit. If you have access to OpenVPN and you want a remote desktop into the virtual machine, you can do that. This will be the username and password, but by the time that you watch this IP address is going to be changed. So whenever you want to connect to this machine, if you have an account with TryHackMe, your IP address would be different to actually remote desktop into it. And inside the VM, we have installed a CAPA software, so it's already there. So we can learn how to run it and experiment further with the different command parameters. It takes a long time to finish using the attached VM, so we have pre-process the reports such as the following. So we actually have these reports that are generated for us. They'll give us some examples of how to run the commands and the parameters that we could use, but to save time, they've already generated reports for us that we're going to use to answer the questions inside of this exercise. They are inside of this specific directory, and that is pretty much it. So that being said, let's now actually look at the tool itself. So the overview of how CAPA works. So to run CAPA, you basically need to open PowerShell. Obviously, you want to make sure that you're in the right directory because you need access to the executable file. If not, you need to give it the full path of where this executable is actually located. Once you're inside of this directory, you can then just run CAPA.exe, and that's basically it, right? So the example that we're going to be using is the cryptbot.binary. So the results of this file will be discussed throughout the succeeding task, meaning the very next task. After running the command, we wait for the result, which takes several minutes. We don't intend this to finish, but rather to let you get a feel for running the tool. So we suggest that you continue the task while CAPA is running to stop the process from running. So there are alternative ways to proceed with the analysis of the results, and this is one way. They have blocked this out because I'm guessing we are going to be trying to do it. Oh no, that's the success bar. So that's the completion bar. So this is what it looks like when it's completed. It went from 0 to 100%. And that's it, right? So you give it the executable, you use the executable, and then you give it the location to the binary file that you want to examine, and it'll start analyzing that program. We have the dash H menu, which is usually what is available to get to the help menu. Then you have V for verbose, and then VV, which is very verbose, and that has to do with how much detail is displayed onto the screen for you. As it's developing, right, as it's running, it'll print stuff onto the screen. Then it'll obviously give you the same type of verbosity, the same type of extra detail when it creates its final report for you. So this is what it would look like when it's finished. So we actually have the binary analysis. So you have the various MD sums that are available for it. So the MD5, SHA-1, SHA-256, these are the checksums, the hash values that are associated with this specific binary. The analysis was static. The OS is Windows. Format is PE because it's a executable file. This is the architecture, and then this is the path of where it's actually located. Then we have the attack technique and the attack technique. And these are from the MITRE attack framework, as we saw already. And there's a lot of different tactics and techniques that are available. And then you have the MAEC category and the value for it. So it falls under malware, and it's a launcher type of category or launcher type of binary. Then there is the objective and the objective behavior. So anti-behavioral analysis, so the virtual machine detection, and then anti-static analysis, so executable code obfuscation, communication, data, defense evasion, all of these various details come out of it. So you can see it's a very, very detailed output that we get from our lovely CAPA tool, which is amazing. So this is where the capabilities kind of come in, right? So it actually lists the various capabilities of this binary. So referencing the anti-virtual machine strings, and then targeting the VMware, targeting VirtualBox, contains obfuscated stack strings. So this is actually, I believe it's even used to work inside of virtual machines or against virtual machines, from what it kind of says. Contain obfuscated stackings or stack strings, reference HTTP user agent string, check the HTTP status code. This is pretty crazy. So, I mean, I'm not going to go read this line by line because it would be a lot of reading to do, but you can essentially pause the video and just read through these things if you're really interested. So since we know that the processing time takes several minutes, we have pre-processed this to a file, which is the cryptbot text, which is going to be the report basically that we see right here. That entire report is exported for us inside of this text file, which is again inside of the CAPA directory. At the same time, this has been attached to this task. By clicking download task files, we can also get this on our desktop, on our machine that for me, for example, on my computer, I can download it. I'm not going to do that because it's already available in the virtual machine and I'm running the virtual machine. So I'm just going to use the report that's inside of the virtual machine. So we can open another PowerShell terminal and then use the command get content cryptbot.txt, or you could just double click it since we're inside of a Windows machine, and then it would actually load the content for you, and it'll give you the same output that we saw from the terminal essentially. And that's basically it. So what command line option would you use if you need to check what other parameters you can use, which is basically the help command, right? So we would do -H for this. What command line options are used to find detailed information on the malware? Use the shortest form, so that would be -V for verbose. What command line option do you use to find very verbose? And it's kind of in the question, which is the VV. What PowerShell command would you use to read the content of a file? And this is a commandlet that's inside of PowerShell to actually read the contents of a file, which is get content. And that's pretty much it, right? So it's very simple to actually run this thing. You basically just use the name of the software. It's either CAPA or CAPA.exe, whichever one you want to do, as long as you're in the location that actually stores that executable file for CAPA. And then right after that, you give it the path of the binary or the executable that you're analyzing. And in this case, when you see // that means it's in its current directory. So it's actually inside of this directory. So let's go look at it real quick because I want to show you this. Let me zoom out and I'll show you what it looks like inside of the actual virtual machine that we have. So we're going to do show split view. That's our virtual machine that has loaded for us. And on the desktop, we should have something called CAPA, and right there it is. So if I open that, I can see that inside of it, I have the CAPA cryptbot binary and the text, and then VV.json and VV text. So these are all of the reports that we have over here that are available for us. The executable that we need to look for is inside of it's actually inside of the administrator's desktop. So the desktop CAPA file, which is over here somewhere. So I think it's literally this piece right here. So it's this actual CAPA location. So the reason why they said go inside of the directory is because the binary is inside of the directory. So if it's not inside of the directory, or if you are not inside of the directory, instead of doing just the name of the executable for CAPA, or just instead of calling on the CAPA tool and then giving it this location for the binary that you want to analyze, you would have to give it the full path. So in this case, it would look like this, right? So I'm just going to open it just so you can see. Essentially, if I don't go inside of the directory that holds this binary, what I would need to do is I would need to actually do, C, and then is PowerShell even loaded, bro? This machine is slow, clearly. So this is what you would need to do, basically. You would do from any location, right? You can run the CAPA executable from any location inside the computer. But what you would need to do is you would need to give it this full path right here, and then do the / and then cryptbot binary. So you would do the executable, and then you would give it the full path of where this binary actually sits. So in this instance, they just told us to go to the location of this binary, and then you just say / and then give it the name. And this dot represents the current directory that you're in, meaning it actually represents this location right here. And then you just do / cryptbot.binary, and that's it. So that's how you would run it, and then you get the report, and then it also generates the report output for you, which is what we see right here. We have the text, very verbose JSON, and very verbose text. So that is the intro to this thing. So now we're going to learn to dissect the results. The very first block of the output that we get has to do with the general information and the MITRE and MAEC data. So it gives us the algorithm hash values, which is, the MD5, SHA-1, 256, etc. It gives us the analysis field that shows us how CAPA performed its analysis on the file. The OS field reveals the operating system that we're on. The architecture field, or the arch, allows us to determine whether we're dealing with a binary related to the x86 architecture, and then the path itself is what we actually analyzed, right? So it says, I386, etc. So this is essentially what we just saw in the report in the last section that we were in. It gave us all the hash values. It gives us the type of analysis that it did, the operating system that it was running on, etc. The MITRE attack portion This gives us the adversarial tactics, techniques, and common knowledge. And this is a very comprehensive global repository, which we already looked at. And it functions as a strategic playbook that provides you details on what people have done. So you already saw that we had the initial access techniques, and then we had maintaining a presence, which is also known as persistence, escalating privileges, evading defenses, all of these things. And there's dozens. At the very least, I think there's like 13 or 14 different columns. And then within each one of those columns, there's like hundreds of strategies. So it's a very, very robust website, obviously. So the MITRE attack website, as you saw, has a lot of intelligence inside of it that you can use. So the format is what CAPA uses for its output, so that and just some of these results may or may not contain the technique and sub-technique identifier. So that's one thing to just keep in mind, I guess. So this is the format is like this. So you have the attack tactic, then you have the attack technique, and then you have the technique identifier. So defense evasion would be the tactic, the technique would be obfuscated files or information, and the identifier would be T1027. So this is defense evasion would be the tactic, obfuscated files would be the technique, and then T127 would be the identifier. Same thing over here. For the format that we have over here, let's see. So attack tactic, attack technique, attack sub technique, and then technique identifier, and then the sub technique identifier. So it's more detailed information. So defense evasion, obfuscated files or information, indicator removal from tools, and then you have the technique ID, and then we have the technique ID or the sub technique identifier, right? So tactic, technique, sub technique, and then the ID, and then the sub ID. So this is, again, the breakdown for it. So this is what we would see over here. So we have defense evasion would be the tactic, the technique would be this, and then the identifier is this. And then we have this again as the technique, and then we have the sub technique from the tools, and then we have the identifier, and then the sub identifier. Same thing for this virtualization, sandbox evasion, system check would be the technique, and then identifier, sub identifier. So this is the way that we can analyze this, right? So under defense evasion, there are, 3 overall techniques, and their relative sub techniques. And then we have under discovery 1 is there, execution has 2, 2, and then impact has 1, and persistence has 2. And all of this had to do with that same CryptBot binary. So in the CAPA's final output, they reference the MITRE framework. This helps analysts or defenders map the file's behavior to the adversary playbook, which can help narrow down the scope of the investigation during an incident. To dig deeper, you can go and look at the full videos that we have for MITRE attack. So essentially, when you see what attack tactics and techniques are associated with any given binary or any given attack, you can kind of guesstimate what their objective was, what they were trying to do, right? So they want to hijack your resources, they want to run some scheduled tasks at a specific thing. They're looking at scripting interpreters for PowerShell, so they're going to be using that. They want to go look at file and directory discovery, so it sounds like they're trying to do reconnaissance. They want to avoid evasion, or they want to avoid sandbox detection or virtualization, and they're looking at obfuscated files or information. This is some of their tactics to actually avoid your defenses. So once they've avoided your defenses, or evaded, once they've evaded your defenses and actually gotten into your network, what they want to do is they want to start looking around and do some reconnaissance. They're probably going to execute some command inside of PowerShell and try to access shared files and try to hope maybe hijack your resources or exfiltrate some data. And then what they're going to do is, in order to persist, meaning in order to actually stay in your systems, they're going to create some kind of a scheduled task that will run regularly, which will most likely execute some kind of a reverse shell that was generated for PowerShell. So I'm guessing, I have no idea if this is what they were trying to do, but this would be kind of the way the thought process would be. Okay, they want to evade the defense, obviously, because they want to get in. They're doing some reconnaissance. They want to execute some commands, and they want to hijack our resources or steal resources, steal data from us, and then they want to stay in our system. So they're going to use a variety of scheduled tasks to do it. So then there's the MAEC or MAEC, whatever, the malware attribute enumeration and characterization, which is the language that's designed to encode and communicate complex details concerning malware. So it's an extensive range of attributes, including behaviors, artifacts, and interconnections among various instances of malware. And this language functions as a standardized system for tracking and analyzing the complicated complexities of malware. That's just a very fancy sentence. So the MAEC category would be malware. MAEC value would be launcher. So if we looked at the table to see the most commonly used values by CAPA, you would have downloader and launcher. Launcher exhibits behavior that triggers specific actions similar to malware behavior. Downloader exhibits behavior where it downloads and executes other files, usually seen on more complex malware. So once it's been launched, it'll download and execute other things. If it's just a launcher, then it'll trigger specific actions similar to basically whatever the malware behavior was. So these are two commonly used values by CAPA, which is either the downloader or the launcher. Now, obviously, if it's once you launch the executable, so let's say we launch that binary file. Once we launch that, if it starts downloading other things and executing those other files that it downloads, obviously it's much more complex than something that will just, once you launch it, it'll just do whatever it's trying to do on your computer. So if it's downloading a bunch of other things, that means it needs a bunch of other things, which means it probably is trying to do a bunch of other things. So CAPA tags a file with a launcher. It indicates that the file demonstrates behavior similar but not limited to dropping additional payloads, activating persistence mechanisms, connecting to C2 servers, and executing specific functions. C2 servers are command and control, which is basically somebody remotely connecting to your machine and then being able to take control of your machine from a remote location. And the C2 server would be the server that's existing somewhere different from your building, and it's connecting to your location, and then the attacker is connecting to the C2 server to use it as kind of a proxy between themselves and you, so that if you reverse engineer the connection and try to find where the C2 server is, you won't be able to find the attacker. You basically only find the server that they were connecting to take control of you. So some of these behaviors are also present in Malware Behavior Catalog, which is MBC, and Capability Block, which we will discuss later. So when CAPA tags a file with a downloader, it means that it's going to fetch additional payloads or resources from the internet. It's going to pull in updates, execute secondary stages, and retrieve configuration files, which just by itself, just by that list of stuff, you can see that it's much more complex than the previous one. So what is the SHA-256 of cryptbot.binary? So if we go up here and just look at this is a SHA-256. Let me make sure I have the full thing highlighted. So we're going to copy that. We're going to go to the bottom and we're going to paste it over here. And that should be the answer. What is the technique identifier of obfuscated files or information? So we want the technique ID of obfuscated files or information, which is T1027. And that is that answer. Let me make sure I get that. Very good. What is the sub-technique identifier of the obfuscated files or information? So with the second item that we have over here. And the sub-technique is 005. So that one I can just type in. I don't need to do the whole. Oh, I need the full thing. So it's T1027005. Okay, whatever. Man, I could have just done that without scrolling up and down. Gosh. Okay, great. And then when CAPA tags a file with this MAEC value, it indicates that it demonstrates behavior similar to, but not limited to, activating persistence mechanisms. So if it's activating persistence mechanisms, it means it is a launcher. So that's what we have over here. And when CAPA tags a file with the MAEC value, it indicates the file demonstrates behavior similar to, but not limited to, fetching additional payloads or resources. So this is obviously a downloader. And voila. Okay, cool. So we got the general information and MITRE and MAEC categories and all that stuff done. So now we need to look at the malware behavior catalog. Under the malware behavior catalog, we have the malware behavior catalog itself, so which is the catalog of malware objectives and behaviors. And then we have the objective, the micro objective, the MBC behaviors, micro behaviors, and then the methods. So let's look at the terminal output here. The terminal can also be in from task 2. So this is basically the same thing that we saw from task 2 when we looked at the full report. So the objective would be on here. So these are all of the objectives. So anti-behavioral analysis, anti-statistic, communication, data, etc. So the behavior would be virtual machine detection, executable code, HTTP communication. This was a long list. So if you remember, there was a lot of stuff that was available under this specific section. So we're going to look at the catalog to better understand the block that we just saw. So this is the catalog. It's designed to support various aspects of malware analysis like labeling, similarity analysis, and of course standardized reporting. So essentially it serves as a catalog of malware objectives and behaviors, and it can also link to attack methods from the MITRE framework to log all the behaviors and code features discovered during the analysis. It's important to note that the name of these behaviors may or may not match the corresponding attack techniques, and the information on behavior pages complements the content on attack pages. In other words, when recording malware behaviors, MBC uses references from attack, or MBC users will reference the attack, but MBC does not duplicate the attack information. So this is the content, as we can see in two formats, right? So the format is the objective behavior and then the method as well as the identifier. So objective would be anti-static analysis. The behavior would be executable code obfuscation. The method is the argument obfuscation. And then this is the identifier. Then we have the objective behavior and identifier. So communication, HTTP communication, and then that's the identifier. The difference is that the first format contains additional details called the method, which can also be coined as the sub-technique. So this is what we see right here. The method, which is in this case the argument obfuscation, that is the method or the sub-technique in this case. So objective. These are based on the attack tactics in the context of malware behavior, though they're not all included, and it has anti-behavioral and anti-static analysis. These objectives are tailored for malware analysis with the use case of characterizing malware. So this is the table that we have over here. So anti-behavioral analysis, anti-static analysis. I mean, I really don't want to read this whole thing, so I'll do this for you, okay? I'm just going to leave this here for a couple of seconds. Feel free to pause it, and then you can read through it, and then we will reference, I'm sure we're going to reference these to answer the questions that come up later. But this is just a bunch of data that's available for you, and you can get the full list of all of the stuff that's on the MBC, on the MBC by going through their documentation. So this is what is available for the, for the characterizing malware portion, I believe. And then so we have the view more objectives. So these are the rest of the objectives that are available. So if you wanted to, again, pause through this and read that. So there you go, 1, 2, 3. And then there we go, 1, 2, 3. And then we have the micro objectives, which are associated with micro behaviors, often referred to an action or actions exhibited by potentially malicious software that isn't necessarily malicious and may serve various objectives. These could be the stuff that's inside of messaging apps as an example. So it's important to note that these behaviors are typically abused. That's why CAPA might have flagged this behavior. So exhibiting behaviors related to processes that are not limited to creating processes, setting thread context, terminating processes, checking mutex, memory, meaning allocating memory or changing memory protection, freeing memory, exhibiting behaviors such as, but not limited to, DNS, the domain name system, file transfer protocol, hypertext transfer protocol, internet control message protocol, simple mail transfer protocol, all of these things, right? And of course, behaviors that check strings, compress data, decode and encode data, all of that stuff. Then we have the MBC behaviors. They contain behaviors and micro behaviors with their identifiers, and then we have the MBC summary for a listing of all of its contents, which is available on their GitHub repository page. And then you can see that there is a long list of stuff that belongs inside of this tool simply under the malware objectives for MBC. So let's just be let's be honest, let's be clear here. There's a lot of data, and to save time and to not bore you to death, I'm not going to sit here and read all of these things, but it's important to note that there's an objective, there's a behavior, there's an identifier, and then in this case, we also have explanations. So again, 3, 2, 1, and then we'll go here, 3, 2, 1. Feel free to read through that as you will. Micro behavior, also known as low-level behavior, refers to the actions that are exhibited by malware that aren't necessarily malicious and may serve various objectives. They're documented as micro behaviors in the MBC, and examples of such things could be the creation of TCP sockets and evaluating specific conditions with strings. It's important to note that just because a behavior is characterized as low-level does not mean it's harmless. So it doesn't mean that it's harmful, but it also doesn't mean that it's harmless, because this could still be a part of a larger scheme. So if it frequently utilizes memory allocation as a part of its strategy to unpack itself and execute malicious activities, malware creates a process via WMI or shellcode, is capable of initiating HTTP communication. It can inspect a string to identify specific characteristics, all of that, right? So, and then these are all the stuff that falls under the file system category: creating directory, deleting files, reading files, writing files, all of this information. And then we have the methods. These are included in the results from the previous example. They are tied to behaviors. Therefore, to fully see all of the methods, you got to refer to the actual behavior or the micro behavior that would be relevant. So the behavior, executable code obfuscation, and the method or sub-technique is the argument obfuscation. An explanation would be a simple number of strings and arguments. 2 API calls are calculated at runtime. And then for this behavior, again, we have stack strings. And then for HTTP behavior, we have reading the header, encoding data to base 64, encoding data to SOR, XOR. Obfuscated files or information again, and then we have encoding standard algorithms. So there's a lot of encoding that seems to be taking place. So maybe they're trying to format it for transfer, maybe they're trying to format it for further manipulation. So now that we understand this, we understand the overview of the MBC contents, we should be able to explain the result of the previous example. So we're going to do a quick recap of the results. So this is the objective, which is data, and then the behavior is to encode data base 64. So this is what we see. The MBC objective is data, which exhibits behaviors like checking strings, compressing, decoding, and encoding. The MBC behavior of encoding data has the ability to encode data using base 64 and SOR. Then the base 64 method is malware that's encoded using base 64, which we talked about in the CyberChef video, which was the last video. And then this is its identifier. So this is all of the data that we were able to pull from this portion right here, okay? So knowing this, you may simply say that this file can use base 64 encoding scheme. That's it, right? Nothing. Just that by itself does not seem malicious, because base 64 encoding happens a lot. It happens for a lot of different types of formatting. It makes it easier to transfer data without using a lot of bandwidth. So it's not necessarily a bad thing, but it could be a part of a larger scheme of activities that could be intended to be a bad thing, okay? So just keep that in mind, right? So we did, again, as they said, like this may not necessarily by itself just be bad, because base 64 encoding is used so frequently across so many different tactics that are legitimate, but it could also be used to transfer data quickly and decode it later on when it receives to its, when it gets sent to its destination. And then from there, now they've quickly transferred a bunch of data out of our stuff and they're exfiltrating data, which is it kind of ties back to the overall, when we looked at this step by step of the tactics and techniques. It's like, oh, okay, they're trying to evade defenses. They're trying to get in. They're doing some research. They're going to look at our files. They're trying to run some processes so that they can transfer data out. Maybe they can steal some data. Maybe that's kind of what it feels like. So what serves as a catalog of malware objectives and behaviors, and this is the MBC. So let me see what it, malware behavior catalog. That's what it is. Malware behavior catalog. That's what it stands for. Cool. And which field is based on the attack tactics in the context of malware behavior? So in the attack tactics. So let's talk about that. It's fun to say that. So which is, I think it's behavior, right? So behavior is the attack tactics. let me find it for sure. It is actually the objective that's based on attack tactics. I love saying that. It's so fun to say. Gosh, I feel like I have like a very weird obsessive part of me that, like, when I find something that I like, I'm like, I'm just gonna say this until it loses its meaning. What is the identifier of create process micro behavior? The identifier of the create process micro behavior. So let's go find that. Okay, cool. Boom. There we go. C0017. What is the behavior with the identifier of B0009? So this is what I'm gonna do. I'm gonna copy that. I'm gonna do a Control F on my screen and then do Control V. And there are 5 locations that it's attached to. There's the question, of course. There is the identifier right here. So what is the virtual machine detection, right? Is that what the question said? What does it want? What is the behavior with an identifier? So the behavior with that identifier is the virtual machine detection. So there it is. Copy that, and then we're going to click down to go to the question. Come on, go to the question. There we go. Boom, just like that. Little cheats here and there. Malware can be used to obfuscate data using base64 and XOR. What is the related micro behavior for this? So obfuscating for base64 and XOR, which are right here. So the micro behavior is the MBC behavior encode data. Is that information? And which micro behavior refers to malware is capable of initiating HTTP communications? So it's capable of initiating HTTP communications. Let's go find that. It is right here. It's under communication, HTTP communication. I think that's it, right? So that's the micro behavior that they're looking for. Yes, excellent. Boom. And just like that, we were able to finish those questions. So now we can talk about namespaces. There are 2 main topics to keep in mind here. We have the capability and namespace, and we're going to be focusing on namespace right now. So this is the CAPA executable output, and it can be viewed in task 2 again because we have the full thing. And this was the long list of stuff that was available over there. So there's the capability and then the namespace that's associated with it. And the namespace seems to just be the path of wherever this thing has been associated with the actual capability itself. So whether or not the path is inside of the CAPA or inside of the computer is a different thing. So the content of the block is represented in this format. You have the capability or the rule name, we have the top level namespace, and then you have the namespace. So reference anti-VM strings is the capability, anti-analysis, anti-VM, and VM detection. That would be the top level namespace, and then you have the namespace, right? So namespaces group items within the same purpose. So anti-analysis, collection, communication, compiler, data manipulation. These are the categories. So these would be the top level namespace. Think of a top level domain, right? So top level namespace would be this, and then this contains a set of rules specifically designed to detect behaviors exhibited by malware, to evade analysis, so anti-analysis, collection, because it enumerates and collects data for exfiltration, communication, meaning that it will do different communication behaviors demonstrated, compiler, sets of rules to recognize specific build environments or compilers employed in generating executables, and of course manipulating data, which means altering data within the executable, or really string encryption or data encoding, anything else that has to do with the manipulation of data, which is it's a pretty big list. And then we have the other executables that are the other top level categories, right? The top level namespaces. So it's an executable. It could be a host interaction. It could be impact, meaning that it affects the computer's behavior or the program's behavior. And internal, meaning it's not intended by an analyst for reporting. Instead, they're meant for internal purposes with the CAPA tool. The library, so building blocks to create other ones. Linking, involved in linking or dynamically loading external code or libraries. Load code, malware family, nursery, persistence, runtime, targeting, a bunch of stuff, right? So again, just in case you wanted to read it. But again, you can also find this just looking at the CAPA documentation. So 3, 2, 1, if you want to read that stuff. We have 3, 2, 1, and then we're going to go here, 3, 2, 1, and then we're going to go down here, 3, 2, 1, and then so let's look at how this works by checking the table. So we have anti-analysis, and then the namespace is anti-VM VM detection, and then rule YAML file. So if you want to actually create or if you wanted to find a YAML file that actually has a YAML rule in it, which is used for detection, which is very useful. These are the YAML files that are associated with it, and then we have the explanation. And the same thing for obfuscation. We have the YAML files for creating YAML rules. Again, very useful, especially if you want to do detection engineering. YAML files are amazing. They're very, very useful, and they can be used in a lot of different contexts. So this is beyond the scope of this. There's a couple of videos on the channel about YAML, and Yara. So Yara rules and YAML files, all of these things are very useful for detection engineering, but that is beyond the scope of Cybersecurity 101. So we only use anti-analysis as the top level namespace. Under this, we have grouped namespaces like anti-VM VM detection, obfuscation. Each has a collection of rules inside them that are also grouped together. For anti-VM detection, we have the rules of reference anti-VM strings targeting VirtualBox, right? Reference anti-VM strings targeting virtual PC, etc. Same thing for obfuscation. It has its own YAML. So do note that this is still under the anti-analysis top level namespace. So this is what it would look like visually. Let's see if we can open this up a little bit. That's not bad. That's kind of cool. Let me see if I zoom out of that. There we go. So there we go. Top level namespace, namespace 1, namespace 2, and then the rules that are associated with the namespaces. That's kind of the best way that we can look at it. There are still a few more namespaces under anti-analysis. If you want to look deeper, we can obviously go into the link that includes the CAPA rules for the MBC project. The MBC project is available at the MBC project GitHub, and then there's a bunch of different subcategories of, or I guess we can call it directories, subdirectories under it that you would be able to look for example, CAPA rules, or Cuckoo, or the MBC Markdown, MBC Sticks, MBC Sticks 2.1, etc. There's a bunch of stuff, and this is all under the Malware Behavior Catalog. So just keep that in mind. So now let's answer these questions using the information that we just gathered. So which top-level namespace contains a set of rules specifically designed to detect behaviors, including obfuscation, packing, anti-debugging, exhibited by malware to evade analysis? So that would be the anti-malware, I want to say, or anti-analysis, I want to say. I think that's what it was. Anti-analysis. Which namespace contains rules to detect virtual machines environments? Note that this is not the top-level name or the top-level namespace. So it contains rules to detect virtual machine environments. So I wonder if I just copy this and search for it into the screen, if we can actually find it. And yeah, so there's this, and then we can go to the next one right here. So this is so it says not this one, right? So I want to say it is this. So anti-VM detection or anti-analysis, is that what it would be? So it says which namespace contains rules. So note this is not the top level name. So I see. So this is this piece right here. This is the actual namespace. That's what they're talking about. So boom, we got that. And then we're going to go over here and paste it. Boom. Which top-level namespace contains rules related to behaviors associated with maintaining access or persistence within a compromised system? So we'll do the same thing. And in this case, there is no block of text that's associated with that. So what we can do is search for maintaining access. I feel like that might be available. There we go. So maintaining access obviously has to do with persistence. That's kind of a gimme. I should have already known that off the top of my head, because persistence has to do with maintaining access. Which namespace addresses techniques such as string encryption, code obfuscation, packing, and anti-debugging tricks? So let's do code obfuscation. Could be the technique. So if we go look for this, there's 11 references to this. So let's see what we can find. Code obfuscation would be obfuscation, which is also under anti-analysis. So I wonder what it's obfuscation, right? That's the answer. So obfuscation. Which top level namespace is a staging ground for rules that are not quite polished? So let's go look for that. And there we go. We have it. It's like it's a little bit cheating, right? So the nursery is a staging ground that contains rules for those who are not polished yet. So let's go to nursery. Awesome. So proceed to the next task for the second part of the discussion, which has to do with capability. So we're talking about namespaces, and now we're going to talk about the capabilities. So now we have another table that has to do with the capability and the related top level namespace, the actual namespace, and the rules that are associated with the YAML file. So this is it. So let's look at this one. So capability, which is here, top level namespace, namespaces, YAML file, and notes. So check all rules under this namespace, clear. Click here. You may check the top level namespace for this, which is under anti-analysis, communication, so on and so forth. So feel free to read through that. We're going to have to do the command find portion of this to actually be able to find these things. And now we have reference base 64 strings, encode data containing a thread local storage, get a common file path, create directory, delete file, read file on Windows, write file on Windows, get thread local storage value, allocate or change RWX memory, create process on Windows, reference cryptocurrency strings, link function. This is insane. This is a very long list, okay? So to further explain this, we're going to check the first capability, which is the reference anti-VM strings. So we noted that the related rules in YML format are referencing the anti-VM strings.yaml, and this is under the namespace anti-VM VM detection, which is also under the top level namespace anti-analysis. So this tells us that CAPA was able to identify that the potentially malicious software searches for VMware specific registry keys and the presence of VMware tools or other VM related elements by using the reference anti-VM strings YAML. So malware typically does this behavior to avoid being detected. That's why CAPA flagged it. So we can have another example, the scheduled task via scheduled task, basically, which is a part of the Windows operating system. So we note that the related rule in the YAML format, scheduled task via scheduled task YAML, is under the namespace scheduled task and the top level namespace persistence. So it could identify behaviors related to scheduled task within the Windows operating system. It might have recognized patterns indicating that the executable registers itself as a scheduled task to maintain persistence using the rule defined in the YAML file. So have you noticed something? The item under capability has the same name as the YAML file under the rule, which with the addition of a dash between the spaces, so scheduled task via scheduled tasks, and then scheduled task via scheduled task, which is this thing, right? So you have that with just a dash in the middle of it, simply because the capability is the name of the rule. So we want to take note of some exceptions where the capability or rules are not located under the namespace. Let's take the capability reference cryptocurrency from the table above. This should be under the impact, which is what we saw. If you go through the folders, you won't be able to find the corresponding rules. It will be located under the nursery and is a placeholder that are not quite polished yet. So now that we have an understanding of capability namespace, we should be able to explain what we got from the actual scan that was ran against our binary file at the very beginning. So we have the capability, which is referencing base 64 string, and this falls under the data manipulation encoding base 64 namespace. So the explanation is here. The capability is referencing that. So it has the ability to encode data to a base 64 scheme. Top level domain name is top level namespace, is data manipulation. So it governs the behavior involved in altering data within the executable, and it can be considered data transformation of malware behavior encompassing actions like string encryption and data encoding. And then we have namespaces, which is the encoding and base 64, and rules for encoding and decoding data using base 64 and XOR. And the YAML file was reference base 64 string, and the capabilities is also the rule name with an additional dash. So reference base 64 string, which is what we see here, and this is the YAML rule for it, reference base 64 string YAML. So you may say this file can use the base 64 encoding scheme, which we established earlier. So it kind of feels like we just repeated the same thing, but we just got some more detailed information on how we got to that conclusion. So what rule YAML file was matched if the capability rule name is check HTTP status code? So it would be check HTTP status code.yaml. That would be it. What is the name of the capability if the rule YAML file is reference anti-VM strings? So reference anti-VM strings. And which top-level namespace includes the capability or rule name to run PowerShell expression? So let's do that and then go and search for that. So run PowerShell expression is load code is the top level, right? Is that what it is? Let's see what this is. Yeah, top level is load code. So let's do that here. We're going to do load code. Check the conditions inside. Check for Windows Sandbox registry from this link. What is the value of the API that ends in EX? What is the value of the API that ends in EX is it looking for? That's kind of weird. Okay, so we're going to check the conditions. And then what is the value of the API? So YAML files are very, very useful. So the rule itself is this, and you can see it's kind of hierarchical. So this is the rule, and then there's some meta information about it, and then we have the features, etc. The meta information, in my opinion, really is kind of irrelevant. It's just basically the information about the rule. It's not that big of a deal. The features would be, okay, this is the API that we need under a condition. This is another API. This is the substring for it, and this is the string. And it says the API ending in EX, which is the reg open key EX. That's basically what we're looking for here. And so we're going to go over there, enter, and we are good. YAML files are very, very useful. And as you can see, they're not complicated to write, right? So again, with the exception, so you could technically avoid all of that. Like you could delete that whole thing as long as you have this section right here. This YAML file will be functional. I would not recommend that you would delete all of this. This is usually especially if you're planning on distributing it to other users so that they know what attack framework it was used, etc., etc. But if you're just trying to write it for your own environment to detect certain things, then you don't really need all of this, as long as you know how to actually write the rule, which again doesn't seem complicated, right? So it's like it needs to include this AND operator, which means that in addition to everything else, it needs to have this API, substring, and string. All of these things have to match because they are all under the AND operator, which means that essentially as long as all of these things are present, this rule is going to be triggered. So there is that. All right, so let's move on to more information and more fun. So what's nice about the CAPA tool is that when you actually use verbose or very verbose, it'll actually tell you things like, what rule was matched that actually triggered all of the data that we got. Excuse me, I keep hiccuping. So if you do it with CAPA and then you do very verbose and then you still do the analysis on that binary, it'll give you the results that we saw in our, we see that we have the very verbose output over here. So they generated a very verbose report for us that we can kind of see in our document here in our lecture notes. So we'll get more detailed results, and if we look at the get content, we'll be able to see all of the information that is available. So this is the web explorer that allows us to look at it if we wanted to look at it in the HTML format or in the JSON format that's available over here. So this is what it looks like. This is the web page for CAPA, and it gives you the information to actually install CAPA, the instructions to be able to install it, excuse me. And then this is a screenshot of when it analyzes it and you're using it inside of the GUI of the website instead of looking at it inside of your terminal. So the terminal sometimes isn't as user-friendly, and it's also not as organized as what you would see here, because technically it still has it, right? So it still has the data, the rules that were triggered, and then it shows you that 31 rules were triggered, 22 namespaces were generated, 9,522 functions, etc. All of this is for this binary. You have the SHA-256 hash value, so it's much more organized. It's a lot more user friendly to be able to look at it inside of an environment like this instead of having to look at it in a long text file or on your terminal. So what we're going to do is we're going to be able to explore this information. So we'll review some of the capabilities, and then this will give us a better idea. So we're going to go through the first example. We know the capability was to reference anti-VM strings targeting VMware, and the corresponding rule was anti-VM strings targeting VMware YAML. So this is the image. So we have this, and so we have the or regex VMware iVMware. So now we can see right here. So this is the or operator, meaning so if this shows up, right? If this regex pattern actually shows up and it's looking for VMware /VMware /I, and then inside of this, there is this specific string that is being searched for that shows up under the regex pattern. This is actually going to be triggered. So we're going to look at the rule's contents. Now we have the rule, and then we have all the metadata, as we already talked about, and then these are the actual key features of it. So it says or string. So let me zoom in on this a little bit better. So it says, features, and under the or operator, meaning any of these things. If any of these things are present, this is going to be triggered. So we see VMware I, VMware tool, a bunch of stuff. And then inside of the description, there's this string description, this string description, this. And these are all of the various options that if essentially any of these things are present, this YAML rule is going to be triggered. So under the features, string VMware I is being referenced by CAPA Web Explorer, and it's saying that under this namespace, we could identify strings with the value of VMware by using the conditions within the rule. And then this is what it will look like again. So up close function, and it matches host interaction process create. So this has to be present in it. So if it's going to create a process, or any of these things would be present. So schedule task exe, create, this would be a command potentially that would be run. Both of these are regular expression patterns, the regex patterns. So as long as these things are present in any of these elements, and it also matches a process creation, then most likely it's going to be triggered. So this also applies to this rule that we see right here, so which is the very first rule that we looked at. So features, again, this is the meat of the rule. So we can see that, yes, it has to match this, or this is available, or this is available, either of these two. So if it matches this and, right, or excuse me, if it matches, when it says and, means this has to be there, and then either of these have to be there. So when it says and this, and then or, meaning either of these two. So either this one or this one combined with this one. As long as those things are present, this rule is going to be triggered. This is beyond the scope of this video. I'm not trying to teach you how to write YAML rules, but I want you to kind of understand what this is like, right? So under the feature string schedule task create is referenced by CAPA. CAPA is saying that under this namespace and by using these conditions within the rule with regular expression patterns, we could identify strings with a value of schedule tasks and create. So this is our final piece right here. Another cool feature of this is the filter option and the global search box, which are helpful. So you could actually search inside of the information. So schedule tasks via AT, and it'll actually show you the rule that would be associated with it, and the namespace that's associated with it, and the attack techniques that's associated with it. So I would say the graphical version of it that's on the website is much more user-friendly and probably a better way to look at all of the information that we were just generated inside of that report, because I mean, it just organizes everything so much better. I don't understand why anybody would not use the Web Explorer. So the Web Explorer is available through this link that they gave to us, the CAPA Explorer Web. So this is also on the github.io, except it's not the GitHub repositories. It's actually the applications that are generated using the GitHub. So you can take note of this domain, or you can just go to that room inside of TryHackMe and get this link. So it's mandiant, mandiant.github.io/CAPA/explorer. And you would end up on this page where you can actually either upload from a local file, meaning upload the actual file of the binary, or load it from a URL, or preview static code, or preview dynamic. So very, very useful. I think this is actually amazing. I'm going to save this into my my bookmarks because that is very handy. So let's see, we got a couple of questions here. So which parameter allows you to output the results of CAPA, into a .json file? So output the results into a .json file. Okay, so this one I actually Googled, and there it is. Which tool allows you to interactively explore the CAPA results in your web browser? And that would be the CAPA Web Explorer. Which feature of this CAPA Web Explorer allows you to filter options or results? And that was the last thing, which is the global search box, right? There we go. So the global search box allows you to filter options or results. And that's it. We didn't even have to use the virtual machine. If I had known, I wouldn't have even wasted the bandwidth on it. That's kind of silly. All right, let's talk about the conclusion real quick. Okay, so I mean, the conclusion doesn't really even give us that many notes either. It just says that we used CAPA to try to do some static analysis. And just for your own information, static analysis is when you look at something without running it. When you run it, then it's dynamic. You're actually looking at what it does dynamically as it's running. When you do a static analysis, you don't run the executable, but you're looking at all of its source code. And if you don't know how to analyze source code, this is where a tool like CAPA comes in, where it actually looks at all of the finer details for you and generates a very, very detailed output, a very detailed report, which is, I mean, very handy. I loved this. For me, this was the first time that I saw CAPA, so I'm actually very excited that it even exists. And now that I know that it exists, as you saw, I already bookmarked it because it's something that I know is going to be useful in the future. So I hope you, at the very least, you go to that domain name and you bookmark it, because you don't even need to have it installed on your computer. That's basically the final note that we got, is that as long as you have that web explorer, you don't even need to have CAPA installed. You can literally just go to that web explorer and attach the file or drop the code or whatever, and you can analyze whatever you need to analyze. If you found this video useful and you would like to get the rest of the videos in the CySec101 training series, as well as all the other videos that are going to come out on this channel, I encourage you to like, subscribe, and turn on notification bell so that you get notified the next time that a video comes out. And of course, drop a comment if you have any questions, or if you want to say hi, or if you have any comments that you want to drop. But definitely make sure that you like, subscribe, and turn on the notification bell, because there's a lot of content that's coming out in the CySec101 training series, as well as the AI for cybersecurity, and then ultimately pen tester and certified ethical hacker, and all of those stuff that's going to be coming out. There's a lot of stuff that's going to come out on this channel, and I think you will be very pleased by being a part of this community. So again, like, subscribe, turn on notification bell, drop a comment, say hi, ask a question, all that good stuff. If you're serious about your CySec training and want access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the supporter, agent, guardian, and master. Each tier gets their own Discord server and early access to content. The agent, guardian, and master levels get exclusive content, bug bounties, exclusive downloads, monthly Python automations, live streams with me every month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you will be able to join Hackaholics Anonymous. I hope I see you in the Discord servers. If not, I hope I see you in the comment section, and that is it. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker/protector. If no one else loves you, Hank loves you. Love, peace, and chicken grease, and I'll see you in the next video later.